Hey there, I'm Matt, and I want to help get you up to speed with developing applications with Ollama using TypeScript and JavaScript. I'm assuming you already know what Ollama is and how to work with it. If not, I have a 10-minute video intro to Ollama right here, which should get you up to speed on all the basics. But you want to start building applications that leverage it. Great! Let's start by looking at how to access the API. So Ollama has two main components. First, there's a client. The client is what runs when you type Ollama run llama 2. It's the REPL that you work with. The other main component is the service. This is what Ollama serve starts up. Normally, you don't do this interactively. Instead, it runs as a service in the background. That service publishes the API. The CLI is just another API client that uses a standard public API, just like whatever tool you're going to write. The service publishes a few different REST API endpoints. You can find these at the GitHub repo under docs and then api.md. Let's start by reviewing these endpoints, and I'll point out some things to keep in mind. It's pretty important to understand the underlying API before we can get busy with the JavaScript library. There are a few different things you can do with the API. You can generate a completion using the chat or generate endpoints. This means asking a question to a model and getting an answer back. You can create, delete, copy, and list models. You can show model information such as the system prompt or the template. You can push or pull a model to and from ollama.com, and you can generate embeddings. Let's look at generating a completion. There are two endpoints here, chat and generate. Both can do exactly the same thing, but which one to use depends on your use case. If you're just going to ask a model a question as a one-off request and not ever hold a conversation with it, then using the generate endpoint makes the most sense. If you need to go back and forth with the model and manage memory or context, then the chat endpoint is just more convenient. Again, you can do everything with both, but if it's just a one-off request, then managing the messages in the chat endpoint is a bit of extra work, which is only valuable in conversations. Okay, so generate can be found at localhost port 11434/API/generate. If you want to use the API on a different host, refer to this video that shows you how to host Ollama on a different machine. For generate, there's only a single required parameter, model. This is the name of the model you want to load. If you call generate with just the model name and the model is already loaded, then the unload timeout will be reset another 5 minutes, with one exception, and we're going to talk about that later. The prompt parameter is the question that you want to ask to the model. This will be inserted into the actual model request based on the template, either that's defined in the model or the template that you specify in this request. Images is in case you work with a multimodal model, such as Lava. You can provide an array of images that are base64 encoded. The model can only deal with a base64 encoded image, so you must perform that conversion yourself. This is an array, but I haven't seen it do anything special with more than one image yet. Notice that the response is a stream of JSON blobs, each specifying the model, created at, response, and done. So most, if not all, of the endpoints respond as a streaming API. We'll see that's a little different in the JavaScript library. Each JSON blob is a token. It looks like most of them are full words, but some of these responses show the parts of words or tokens. Scroll all the way down and you can see the last blob has done set to true and includes the context that you can provide to the next generate call. It also shows all the stats for this generation. You'll notice that it doesn't provide tokens per second, but you can just divide tokens by seconds to come up with that yourself. If you want the response to be a single value after the generation is complete, you can set stream to false. We can see here that the response shows all the tokens in the response joined together. If you set stream to false, then you'll have to wait for all the tokens to get generated. Setting stream to false will not speed up the response and, in fact, may feel slower since you have to wait longer. But sometimes it's useful to turn streaming off, such as when you're returning JSON. So that takes us to the format parameter. This only allows for a single value, and that is JSON. Using format JSON is more than just specifying the format value. You should also say something like respond as JSON in the prompt, and ideally provide an example of the schema in the prompt as well, and maybe even some examples. Otherwise, you run the risk of outputting a different schema each time. The big array of numbers in this output is the context. If you want to provide this answer and continue the conversation with the model, pass this context to the next call to the generate endpoint. But it's a bit of a black box that you can't really control. So if I know I'm going to need to hold a conversation, I'll stick with the chat endpoint. Options, system, and template just override whatever is set in the model file. Raw is there in case you want to handle the system prompt and template yourself entirely. There were some earlier users of the API that managed their own system prompts that needed this. This also removes the context from the output. Finally, there's keep alive. Keep alive defines how long the model should stay in memory. The default is 5 minutes, but you can set it to any time you like, or -1 to keep it in memory forever. If you provide just a number to this, then it will default to seconds. But if you provide it as a string, it has to include an S or an M or an H to indicate the granularity. For the chat endpoint, all the parameters are the same with a few exceptions. The context, system, and prompt parameters in generate are replaced with messages. Messages is an array of message objects that can include the system prompt, the prompt from the user, examples of output, and any memory or context you want to send to the model. Each message has a role, which could be system, user, or assistant. Content, which is the actual text of the message, and optionally images to send for multimodal models. I'll do some more complex examples later when we get to the library. The rest of the endpoints are a bit simpler and should be understandable using the docs. So let's switch gears to working with the JavaScript library. You can learn more about it at github.com/Ollama/Ollama-JS. It's usable on the server side using Node.js, Deno, Bun, and most other alternatives to Node, or you could use it in the browser. Both should behave the same way. I'll be using Bun since it makes Node so much faster and does everything in a more modern, yet compatible way. One of the benefits of the JavaScript library is that it simplifies the switch to and from streaming. The function calls return a single object when not streaming, or an async generator when they are streaming. Okay, so let's get into the code. This will be part of the video projects repo under intro dev tsjs-2024-0328. Since I'm using Bun, I'll run bun add Ollama. This first example is 1.ts. I'll import Ollama from Ollama and move on. The simplest example is just await Ollama generate and set the model to something, and then set the prompt to an empty string. In the REST API, we didn't have to include a prompt, but in the library we do, but we can leave it empty. Remember, this is going to reset the keep alive parameter. But let's set the prompt to something in 2.ts. Why is the sky blue? And we can run it. Notice that we get the non-streaming response. In the API, it defaults to streaming, but here we default to not streaming. I think this makes more sense, but changing the root API means breaking a lot of code in the process. So that probably won't happen until there is a need for a new version of the API. Folks are usually pretty reluctant to do that. So add stream set to true in 3.ts, but we don't get much of a response. So let's iterate through the parts of the output and write that out. But that's a bit hard to watch. So swap out console.log to process.standardout.write with just the token, and that looks a lot better. We can add the stats at the end by looking for done is true, Durations in Ollama are measured in nanoseconds, so we need to multiply it to be useful. In 4.ts, we're going to make a second generate call that remembers the first, then save the value of context from the last blob, and then feed it into the context of the second call. Here I've set the prompt to be vague so that we know it was using the context. We can try again without the context set to verify that statement. Okay, now let's try describing an image in 5.ts. I have a JPEG of my hand in this folder. I found a simple npm module called image to base64 that I can use. I'll add it and then import it. Then just have the model describe the image. Perfect. Worked just fine. Let's move on to using the chat endpoint. As we saw in the API section, it's pretty much the same thing with the exception of how messages work. We can try a simple example in 6.ts. I'll just set a system prompt and then the user prompt. So that means defining an array of messages. Each message includes a role and the content. Then feed messages to the model and spit out the results. For 7.ts, we'll do something a little more complicated using format.json, an example schema, and some example outputs. You see the example in there? I specify a user said Paris, and the model responded with the information about Paris. This helps the model understand what you need. So now, when we ask about Amsterdam, we should get something interesting. There's one more thing I want to show you. Every call we've made to Ollama has been local thus far. So http://localhost:11434 was the base of the URL. But what if you set up a server that's not your local machine? I set up a Linux box on brev.dev and call it Matt's Remote Ollama API. I installed Ollama and pulled Llama 2. Then installed Tailscale and set the machine name in Tailscale admin to Matt's Remote Ollama API. And then set the Ollama host environment variable to 0.0.0.0 and restarted Ollama. Now in the code on my machine, change the Ollama import and create a new Ollama client pointing to the remote host. And now the code just works. I think the rest of the endpoints should just make sense. You'll find other examples using the code in the rest of this repo, which is the code for most of my more recent videos. If anything wasn't clear in this video, let me know in the comments below. It's hard to fix the actual video, but if it's a glaring omission, I can look at making a new video. And join us in the Discord at discord.gg/Ollama. Thanks so much for being here. Goodbye.